The second type of stoichiometry we're going to consider and look at is gas stoichiometry. And this is calculations that involve the amounts of gases. So that might be volume, pressure, or temperature. You're going to follow the same basic 4 steps that you did for gravimetric stoich. The first was writing a balanced equation. Second, calculate the moles of your given substance. Third, use the mole ratio to calculate moles of your unknown substance. And lastly, calculate the amount that you need. Some of your calculations might be at standard conditions, and that was STP and SATP. If that's the set of conditions you're working under, you will be able to use the molar volumes to convert between volume and moles. So for STP, the molar volume was 22.4 liters per mole. And for SATP, that number was 24.8 liters per mole. If any of your calculations are at non-standard conditions, you must use the ideal gas law. The equation for the ideal gas law is PV equals nRT, where R was the ideal gas law constant, and that was equal to 8.314 kilopascal liters over mole Kelvin. Something else to remember is that the units must match the ideal gas law constant units. So pressure has to be in kilopascals, volume has to be in liters, and temperature has to be in kelvins. And remember that magic number to change from Celsius to Kelvin is 273.15. So let's look at a couple of examples. In this first example, we have 2.58 grams of propane that's being burned in a barbecue, and we need to determine the volume of carbon dioxide gas produced at SATP conditions. So again, first thing, balanced equation. So propane is C3H8. That's burning, so it must be combining with oxygen, O2 gas. And this is a combustion reaction. So we're producing carbon dioxide, CO2, and water. When we balance this out, for every 1 propane, we will produce 3 carbon dioxide, 4 water, and we'll use 5 oxygen in the process. We've started with a mass of the propane, 2.58 grams, and we're supposed to be finding the volume of carbon dioxide, so let's write that under the CO2. You might also want to write down the conditions, or in this case, because it's standard conditions, we could write down the molar volume, which is 24.8 liters per mole. So step number 1's done. Step number 2 is to calculate the moles of our given, which is the propane. So that's C3H8. So starting with the 2.58 grams, we want to change that into moles. So moles is going to go on top. We're trying to cancel grams, so they go on the bottom. So we're dealing with the molar mass, and that's 44.11. So your calculation should give you 0.05849 moles. Third step is to use the mole ratio to calculate the moles of the unknown. So that's the CO2. So using the 0.05849 moles of C3H8, we want to multiply by a mole ratio so that we end up with moles of CO2. So we want moles of CO2 on the top and moles of propane on the bottom. Looking back at your reaction, that means that we have a 3 on the top for the CO2 and a 1 on the bottom for the propane. So now we have 0.1755 moles of CO2. Last step, we want to calculate what's asked for in the question, which was a volume. So volume of CO2, we start with the moles, 1.755. And because we want volume, that means we want to multiply by liters over moles. We're at SATP conditions, so that means we can use the molar volume of 24.8 liters for every 1 mole. So your answer comes out to 4.35 liters. In this example, we have a temperature and a pressure, so we're not at standard conditions, so we're going to have to use the ideal gas law. Coal, which is pure carbon, is burned in many Alberta power plants to produce heat for the generation of electricity. Calculate the mass of coal that was burned when 25.7 megaliters of carbon dioxide was produced in a station at a temperature of 627 degrees Celsius and a pressure of 380 kilopascals. The megaliters that we have on the volume of carbon dioxide doesn't have to throw us off here or make any problems. We're just going to carry through that prefix, the capital M, as mega in the calculations, and I'll show you that as we go through. So again, first thing we need is a balanced equation. So we're going to start with pure carbon. This is burning, so it's in oxygen. And we're making carbon dioxide according to the question. Balancing this one is really easy. It's 1 for all of the coefficients. We're supposed to be finding the mass of coal, so we need to find the mass of the pure carbon. 25.7 megaliters of carbon dioxide was produced. So over on the product side, the volume is 25.7 megaliters. And we also know the temperature and the pressure for that gas. So our temperature is 627 degrees Celsius and pressure is 380 kilopascals. The temperature has to be in kelvins, so when you add the 273.15, we come out to a temperature of 900.15 Kelvin that we'll need for the calculation. So first step, now that we have our balanced equation and all of our givens, is to calculate the moles of our given substance. So that's the CO2. So moles of CO2 has to come from the ideal gas law because we have non-standard conditions. So when you rearrange to solve for N, we would have pressure and volume on the top and R and T on the bottom. So if I substitute in pressure, don't have to change because it's in kilopascals. Volume is 25.7 megaliters, and that's okay, we can leave it there. R is the constant, 8.314. And temperature we already converted into 900.15 Kelvin. So that calculation should give you 1.3049. And if you look at the units that are canceling and what we have left over, we will have megamoles. That's okay. Just stick with me. We'll get through this just as we need to. That was step 2. For step 3, we want the moles of our unknown, and that's the carbon. So using the 1.3049 megamoles of CO2, we can multiply by the mole ratio, which is going to be 1 over 1. And that's to give us the 1 mole of carbon and to cancel the moles of CO2. So we get the same number, and we've still got the same units of megamoles. For the last part, we want to change into mass. So we need the molar mass of pure carbon, and that's going to be 12.01 grams for every 1 mole. So when you multiply that, the moles cancel, and now that mega moves on to the grams, so you end up with 15.7 megagrams of carbon. So that mega can just carry right through the calculations. In some of your questions, you'll be able to do this. In others, you won't. Make sure that you check to see which things cancel as you go through your calculations. If things don't cancel and they don't come out to a unit that makes sense, then you might have to go back and convert. In this case, it can carry right through and you can give your answer in units of megagrams.